Hello, researchers. Have you chosen your samples already? I'm talking about the respondents of your research. In a population like this, for example, how many do you need? Should you take all of the members of the population or just a part of it? Today's lesson focuses on sampling and sampling methods. In research, when we talk about sampling, it is the process of selecting samples from a population of interest as respondents to help us in generalizing our results back to the population from which they were chosen. In the vast majority of research endeavors, the participation of an entire population of interest is not possible, so a smaller group is relied upon for the collection of data. At this point, let's try to understand what population means. It's actually whatever group you are interested in. This is the totality of individuals, or be it objects, that are in the focus of your study. This is also called the target population. Sample size is the number of samples needed for the study. This is determined using the Slovin's formula that we will discuss in the next video, so you better pay attention. Finally, the term samples means these are the selected elements chosen for participation in a study. The sample is the group of individuals who will actually participate in your research. They are also called your respondents. To draw valid conclusions from your results, you have to carefully decide how you will select a sample that is representative of the group as a whole. There are two types of sampling methods: probability sampling and non-probability sampling. Probability sampling involves random selection, allowing you to make strong statistical inferences about the whole group. The characteristics of this probability sampling are: number one, all individuals or objects have equal chance to be selected, and number two, could increase samples' representativeness of the population. As a researcher, the secret to minimizing biased data is you go for random sampling. Random sampling simply describes when every element in a population has an equal chance of being chosen for the sample. Sounds simple, right? Unfortunately, it's a lot easier said than done. This is because there are a lot of logistics that need to be considered in order to minimize the amount of bias. There are four types of random sampling techniques. 1. Simple random sampling. 2. Stratified random sampling. 3. Cluster random sampling. And 4. Systematic random sampling. In simple random sampling, individuals here from a sample are selected by a random method. It may be assigning numbers for every member or draw lots of names. Or examples here are like bingo method, computer-generated random numbers table, draw lots, or lottery, also called the fishbowl method. In simple random sampling, for instance, this is your population. Then the researcher assigns number for each. Finally, the researcher takes the first samples that he or she requires. The second technique is called the stratified random sampling, known as the SRS. Here, sampling starts off by dividing a population into groups with similar attributes or characteristics. We call it stratum or strata. Then, individuals are taken from the different strata using this SRS to form a sample size. First, the researcher needs to identify the target population. Then, these populations be grouped accordingly. The grouping according to researchers' purpose is used to ensure that different segments in a population are equally represented. To give an example, imagine a survey is conducted at a school to determine overall satisfaction. It might make sense here to use stratified random sampling to equally represent the opinions of students in each department. Lastly, random sample from each group will be selected. The third technique is called the cluster random sampling. This is used for an extremely large population. It clusters the population using natural grouping. Example, geographical grouping. Then a random method is used to choose a cluster as your sample. In a single-stage cluster, for example, all you need to do as a researcher is you list all clusters. Then, choose clusters by SRS. Finally, all members in the selected cluster are included in the sample. To repeat, cluster sampling starts by dividing a population into groups, called clusters. What makes this different from stratified sampling is that each cluster must be representative of the population. Then you randomly select entire clusters to sample. This, for instance, is a cluster of population based on geographical location, Talisay, Bacolod, Silay. And the last part of the process is that the researcher would choose a certain cluster or clusters to represent the samples. This is another example for cluster sampling. So in grade 10, there are 3 sections. So the researcher would simply be choosing, let's say, only one section as a sample. In this instance, 10C is chosen. The last but not the least is called the systematic random sampling. This is a very common technique. Let's say, for instance, every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. If you were conducting surveys at a mall, you as a researcher must survey every 8th person that walks in, for example. Here's another example of systematic random sampling with the use of the interval of 4. The researcher here randomly selects a starting point. Let's say the starting point is on number 2. From 2, simply count every 4th interval. So we've got 3, 4, 5, 6. So the 6th will be chosen. Count another 4, starting with 6. So we've got 7, 8, 9, and the 10th will be chosen. And so on. So in this group, we've got numbers 2, 6, 10, 14, 18, 22. There are the 4th interval in this group. This 6 will be chosen as the samples. The second method is called the non-probability sampling. This involves a non-random selection based on the convenience or other criteria allowing the researcher to easily select or collect data. This involves selection of elements from population using non-random procedures. The characteristics include 1. Sampling frame is not needed. 2. All individuals or objects don't have equal chance to be selected. And 3. Could result to bias. Sampling bias means the inferences you can make about the population are weaker than with probability samples and that your conclusions may be more limited. If you use a non-probability sample, you should still aim to make it as representative of the population as possible. Non-probability sampling techniques are often used in exploratory and qualitative research. In these types of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. The common techniques under non-probability sampling are the convenience sampling, purposive sampling, snowball sampling, kota sampling, and consecutive sampling. The first is convenience sampling. Here, it simply includes the individuals who happen to be most accessible to the researcher. This is an easy and expensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can't produce generalizable results. Example, you are researching opinions about student support services in our university, UNOR. So after each of your classes, you ask your fellow students, your classmates, to complete a survey on the topic. This is a convenient way to gather data, but as you only surveyed your classmates taking the same classes as you at the same level, the sample is not representative of all the students of the university. Here's another example, the group of friends and a group of not friends. So what could be the researcher's choice? Of course, you know it. The second technique is called the kota sampling. It's a non-random selection of individuals based on the identification of specific characteristics or a set of criteria. Here's an example for the kota sampling. For as long as the individual meets the demand or criteria that the researcher is looking for, then he or she is in, can be already part of the sample. The third is a snowball sampling. This is a non-random selection where existing study subjects recruit future subjects among their acquaintances, criteria, accessibility, of availability. This technique is very helpful if the population is hard to access. Snowball sampling can be used to recruit participants via other participants. Fourth is consecutive sampling. This is a non-random method of collecting samples where the researcher picks a sample or group and conducts research, then moves to another sample until the sample size is met. Fifth is purposive sampling, also known as judgment sampling. This involves the researcher using his expertise to select a sample that's most useful to his research. For instance, you, as a researcher, want to know more about the opinions and experiences of disabled students in our university. So you purposely select a number of students with different support needs in order to gather a varied range of data on their experiences with student services. I would like to add up this sixth sample. It's called the voluntary response sampling. It's similar to convenience sampling in a way that a voluntary response sampling is mainly based on ease of access. Instead of the researcher choosing participants and directly contacting them, people volunteer themselves, example by responding to a public online survey. Voluntary response samples are always at least somewhat biased, as some people will inherently be more likely to volunteer than others. For example, you as a researcher send out the survey to all students of UNOR, our university, and a lot of students decide to complete it. This can certainly give you some insight into the topic, but the people who responded are more likely to be those who have strong opinions about the student support services. So you can't be sure that their opinions are representative of all students of the university. We end right here. I hope you've learned something. See you all in our next video. Bye!